In this video, we're going to look at some identities that are called Pythagorean identities because they're related to the Pythagorean theorem. All right, so first off, if you have a right triangle, let's say it looks like this, and let's call this the angle that we're going to be referring to as theta. And then let me just label the sides. Let's suppose this is A, this is B, and this is C. Okay. All right. If you had a right triangle like that, then you know that A squared plus B squared would have to equal C squared. Okay. So we're going to use that relationship to derive the Pythagorean identities so we can see where they came from. And what I'm going to do first is I'm going to take the Pythagorean theorem that you see right here, and I'm going to divide both sides by C squared. Okay, and I'll go ahead and distribute it to each of these. So I'm dividing both sides by C squared. When I do that, do you see how I get A over C squared? And then here I have B over C squared. And then here I have just 1. Okay, and when you look at the triangle again and you look at that fraction, that ratio, A over C, that's the side opposite theta divided by the hypotenuse. So that A over C could be replaced with sine of theta. And then sine of theta squared, a lot of times we just write that this way. That's the notation for sine of theta squared. When you put the squared like that, what you're really doing is you're saying the same thing as sine of theta squared. But it is just a short way to write that. All right, and then B over C would be cosine of theta squared. Cosine of theta in parentheses squared, and a lot of times we write that by saying cosine squared theta. All right, so that right there is the most important one of the Pythagorean identities. And then it can be used to come up with a couple other ones. So let's suppose we started with sine squared theta plus cosine squared theta equals 1, and we wanted to derive the other ones. Okay, what I could do is come through and divide all the way through by sine squared theta. Okay, so if I did that, then this would equal 1. This is basically cosine theta over sine theta squared. Well, that would be cotangent squared. Let me write that better. Cotangent squared theta is what I'm trying to say. It's cosine over sine squared. So that would be cotangent squared theta. And then 1 over sine squared theta. Well, 1 over sine is really cosecant. So this would be cosecant squared theta. So we have another Pythagorean identity that we could get by taking the basic one and just dividing by sine squared theta, right? And then we could do the same thing, but we'll divide by cosine this time, see what we get, what relationship has to hold true. So I'm going to divide by cosine squared theta everywhere. Okay, if I do that, then I have basically sine over cosine, sine theta over cosine theta squared, and that would be tangent squared theta. And then, of course, that's equal to 1. And then 1 over cosine, well, that's the same as secant. So 1 over cosine theta squared would be secant squared theta. And so here are the 3 Pythagorean identities. Okay, this is really the only one to know, to really you use it so much to memorize that one, and then the others, you could figure out if you needed them. Okay. All right, so now on question number 4, it gives us the value of the sine of theta, tells you theta is an acute angle, and you're supposed to use an identity to find the value of cosine of theta. Okay, and so what we would potentially do here, you might think about it because it came right after the previous exploration, is just start with a Pythagorean identity. Sine theta is 1/2. So we can replace sine theta with 1/2 and square it. And then we can work through the rest of this problem algebraically. So this would be 1/4. Okay, so we're going to work on getting the cosine squared theta by itself. So let me subtract 1/4 from both sides. And so I'm going to wind up with cosine squared theta by itself equaling 3/4. And then I want to take the square root of both sides here. Don't forget to take both. Don't want you to forget your algebra. Okay. And so the square root of cosine squared theta would be cosine theta, and it would equal positive or negative square root of 3/2. And then since we were dealing with the acute angle and all, it would be the positive one. Or the sides of a triangle and all, it would be the positive one. So we'd wind up with cosine theta being square root of 3/2. Okay. All right, I'm going to go ahead on this same video and take a look at these last ones. These are really just calculator questions, so I want you to make sure you have your calculator handy and be working through these with me. All right, so here we're just looking at making sure we can type these into our calculator correctly. So I want you to find the sine of 72.8, okay? So if you got to really make sure that you be careful what mode you're in. This is what everybody messes up on when it comes to quizzes and tests if they're not careful. So check your mode and then double check your mode and make sure you got your mode right. All right, and this said to round to 4 decimal places. So sine of 72.8, that turns out to be about 0.9553. It was really a 2.7, and so we bumped that up to 3 because 7 was bigger than 5. Right, and then we don't have a button for cosecant. So when you're thinking about this one, you need to think about how, well, cosecant is really related to sine, and so the cosecant of 1.5 is the same as 1 over the sine of 1.5, okay? Now look, 1.5 doesn't have a degree symbol on it. The inputs to these trig functions are your angles, but 1.5 doesn't have the degree symbol on it, so that means it's in radians. So you want to change your calculator to radians. Okay, then you want to do 1 divided by sine 1.5. All right, and when you do that, you wind up getting about, got to round to 4 decimal places, I get 1.0025. Okay, so we had to use one of the fundamental identities on that one. Okay, now these two are actually going backwards. So these two are asking you to figure out what was the angle whose tangent turned out to be 26.0307. So I want you to look at your sine, cosine, and tangent buttons on your calculator. On most calculators, right above those will be a relationship that is going to allow you to figure out what the angle is. Okay, so like, you know, if you have a function and you apply it to some input, let me draw that better. Okay, let me start with my input. So say you have some input and you apply a function to it, some function to it, you get the output. All right. Well, there's a type of function that undoes that, that takes you back around full circle, and that would be the inverse of function f. And we a lot of times use that little -1 on the f, but don't mess up. It doesn't mean 1 over f. It means the inverse of function f, but that's just the shortcut notation. Well, the same thing is true with your trig functions, okay? And so, for instance, on this one, if we did the tangent of some angle, and I'm going to use theta here because that's the way we're thinking about it right now, and we needed to do something, we did tangent theta, and we came over here, we did tangent, applied tangent to the angle, and got tan theta, okay, equaled that 26.0307, there'd be a function that would take us back full circles and tell us what the angle was. And we could use that same notation. It'd be the inverse tangent function, tan inverse, we sometimes say. So that's what you have to do on your calculator. What you do is you take the inverse of tangent on both sides, basically. Let me write that so you see how it's actually written. We're just solving this by taking the inverse of the tangent function on both sides. So it's undoing whatever tangent did. Okay. And then those undo each other and give us theta. And then over here, when we do that, we'd get the measure of the angle, and we'd get the measure of the angle, and we'd get it in whatever unit we had the mode set to. So this one says to find the value of the acute angle to the nearest tenth of a degree. So you'd want to be in degree mode. I was in radian from the last problem. So let me switch to degree mode. Then do you see how the inverse functions are that second function above the original keys? And so you should know how to do that on your calculator. I'm going to do second function and tangent. That brings up tan inverse tangent function. And then I'm going to put in 26.0307. Okay. And that tells me that theta was, I'm going to use a squiggle here, was about 87.8 degrees. It said to round to the nearest tenth. So I rounded to one decimal place. Okay. All right. Now this one says to the nearest radian. Okay. So that 0.9499 is the ratio of two sides of your triangle. Okay. Change your mode over to radian. Do sine inverse of both sides. Is the idea. So those undo each other and leave you with a theta. And then you come in and you do sine inverse of 0.9499. Oops, I didn't clear my screen first. Let me try again. I need to do sine inverse of 0.9499. And I wind up getting 1.2. And let's see, nearest tenth. So I get 1.2, and that's radians. Okay, 1.2 radians. Okay. By the way, just to kind of relate it to what we did earlier, an angle that's 1 radian, it's like if you had a circle on here and this was the radius, it would be an angle that's about 1 radius in length. So 1 radius and a little bit more is what you're talking about. So an angle about like that. Okay. All right, so I'm going to stop this one and then do one more video dealing with applications of right triangle trig.